So welcome to the interesting question, is data modeling dead? And this is not a hypothetical question. It started some years ago when I was at a conference in the US, and some very famous data modelers working for big insurance companies already for years in the business asked, is data modeling dead? Because they were doing their job for 20, 30, 40 years. They created value, but they didn't saw how it was appreciated in the company, how it was used, how it was evolved, and they got the feeling that somehow the value of data modeling wasn't anymore seen that much as before. So let's start a little bit on what is data modeling, why we need it in my opinion. Just that you know my background, I'm working for a data warehouse automation tool vendor called Data Vault Builder. And we believe that we should work on business models and that we're converting business models automatically into working code. So that's a little bit of background as well of my personal way of seeing things. But here I try to abstract it a little bit and tell a bit about my professional experience and the history in a very, very simplified way of data modeling. So I started in the data warehousing area in the year 2000. I worked first for a financial institution where we did data reconciliation. We did more image style data modeling. I switched over to telecommunications where I was leading a data management team for a telecom provider where we did more Kimball style stuff. And back in 2012, I had some challenges with Agile data warehousing, near real-time data warehousing, and I tried to use Data Vault as a modeling paradigm. And it worked out well, but we figured out that we need automation, otherwise it wouldn't work, and that was the starting point back in 2012, what 2015 became the Data Vault Builder. And I'm still with the company and we're developing this tool as a software vendor. My role today is pre and post sales and doing this kind of presentations to train people, to enable people to exchange ideas with the community. So what are models for me? They give meaning to things, to very complicated things. So it's a simplification. A model is usually simpler than the thing itself. And if you look up like ontologies on Wikipedia, you will see that there are different kind of elements. We have classes or concepts, we have properties, relationships, and yes, then there are some axioms and constraints. But still, these basic elements of data modeling you will find again and again through all the history, just with different variations, but the basic ideas don't change. So this means if you learn data modeling at some point in time, you will be already set for the future, probably for many years to come. So let's assume what means simplification. If you have a tree with all its leaves and branches and everything, there are thousands of different points. You can't capture a real tree in, let's say, a database or a file. It would be huge, and usually you don't need all this kind of information for doing analysis about your trees, maybe in your business context. So we can do a simpler model and say, okay, this kind of representation is perfectly fine. And it has some green part, some brown part, and it's a tree. And still, if I show you this picture, you will understand that it is a tree. And this is not the simplest way that you can represent that. Even if I show you just the outline of this, you will understand this is a tree. And if I need to count how many trees I have, it will be pretty simple. So this should be enough for many applications. And one very nice picture explaining this kind of relation between the real thing and the model of it is this picture where it says "Ceci n'est pas une pipe." This here is not a pipe, it's a picture of it. It's a simplified version, it's a two-dimensional picture. Still you recognize what it is, but it's not the real thing. So how can we use this kind of models to simplify things, to explain things? So let's have a look at the forest that I have here. If I show you this picture, you say it's a nice forest maybe, but what is this all about? And here we can say, okay, if we get into a business and we want to know how they work with this forest, we can simplify it and say we have a concept of a tree. Many trees are within a forest. There's a forester taking care of the forest, or even maybe several foresters taking care of several forests, so they are reassigned. And there are different species of trees, and we have owners. And already by showing you this kind of simple picture, you would understand what this forest is about. Somebody is owning the trees. They probably want to make a profit, but they need to have taken care of the trees that they can grow and be used later. And this makes it a mean of communication. Now, different people from different business areas in the same company can come together, discuss if they have the same view, they can put in definitions, they can make meaning of things and collaborate. And it's important for collaboration between IT and the business people because they have different perspectives, and this is a layer where they can agree on and say, okay, we understand each other at least enough to work together. So where is this all coming from? And some people claim that Edgar F. Codd was the father of the relational databases. He wrote a very nice book about it. It's about in the 1970s. And when you see that, then you already see this is nothing new. And you will see that all the later ways of data modeling rely on the same principles because it's again and again the same, and I will repeat myself all the time. It's about identifying a thing, describing a thing, and putting things into relations. He as well did work on ACID. That's how transactions are handled in databases, and normalization. I tried to find a nice picture for ACID, but the only thing I found was this here, this happy smiley face. Not sure what this was about. But normalization is the aspect we're interested in. And he split up data into primary keys, identifying a thing, into foreign keys, relating things, and in attributes, describing things. And one of his primary goals was to deduplicate data. So we could split up like customer type into a separate table, so we don't need to put in the full description of the customer type into every customer. We could just have the relation to the customer type. Because we are in the 1970s, storage, memory, and CPU is very, very expensive. So saving hardware costs, even if it comes at the cost of maintainability, is very, very important. So you should never forget the sentence that every attribute should provide information about the key, the whole key, and nothing but the key. So help me God. So if we go further, then what Codd was about was OLTP systems. So online transaction processing, about really managing the business process. But later on, there came in new systems doing reporting or creating a better view about your online transaction data. And here we have a little bit a different aspect. Because we're querying mass data, not only single records, we want to do that really fast. And data warehousing systems live over a long time, and we want to see the history, how stuff changes. If people change the name, if customers that were leads become customers, stuff like that, how they change, how the customer lifetime value changes over time. And this is the aspect. So online transaction systems, for simplicity of changing stuff, they have often surrogate keys, technical keys. They are not stable over time. It doesn't matter because they live in the moment. And if we go into the data warehousing world, we like to slowly use business keys to identify stuff so that stuff stays stable over time, even if we exchange IT systems. But it has as well some downsides. If I take my name, if I would get married in certain countries, I can take a different name. So if I would define just the name and maybe the birth date as the key identifying me, I would disappear and reappear as a new thing. So models are never perfect. We always need to see, okay, what we want to trace, what is okay, how we can identify stuff, and the world is not perfect. We don't know everything about the world, so sometimes we will miss that I changed the name and we will assume it's a new customer. So let's stay now in this analytical world. And here comes Bill Inman. And 1992, called by many father of the data warehousing, because we have a lot of fathers in here in this presentation, he started building the data warehouse. And he defined it as subject-oriented, non-volatile, integrated, time-variant collection of data in support of management decision. And let's be honest, this definition is still true for many current implementations, or should be. And if you look at some approaches like data lakes and stuff like that, they can solve, if they do it right, this kind of requirements, but some of them don't. And this means that they are not replacing the data warehouse. They replace certain functions of data warehouse, but again, you need to add this functionality later by using different means, which is not impossible, just that you know, only if you solve all of these topics like integrating data, making non-volatile, time variant, then you have the full picture. And he used as well 1992, database systems are getting better, relational databases are getting better, the third normal form to relate data to each other. And additionally to the primary and the foreign key and the attributes, he added surrogate keys. Why? Because he wanted to save different versions of this information about a certain primary key. Like if I change my name and the company knows about it, so that you could store different versions and you know exactly from which point in time it was valid and which other point in time. The problem of this is maintainability, because we have here foreign keys, and the foreign keys are pointing, if you have a fully historized data warehouse, to a version of information, meaning that if we change like the customer entity, we add two new columns, the history might change. If the history of the customer changes, the history of everything else changes, and this is cascading through your data model. So changes are extremely costly. So in the beginning, if you're starting with an enterprise data model, and you implement a third normal form data warehouse, it can be very simple to implement, very straightforward, but later on, if you get changes, if your sources changes, it was a nightmare. So many data warehouse projects did very good in the beginning and slowly became slower and slower until they died and were replaced by a new solution. Some people came up, especially Ralph Kimball, and said, hey, we should make this simpler. We should take it like from what the people need, and we should think about something that he called conformed dimensions. So he took like the customer and he integrated all the data of the different IT systems into one customer dimension. He denormalized the data, saying storage is in the meantime became much cheaper, so it's better to denormalize the stuff because still compute and memory is expensive. So it's simpler just to denormalize all our information. We can really query it in a very simple way with only a few joins. The second thing that he did is that he has built very lean fact tables just referencing the different dimensions. But still the problem with maintainability stayed a little bit, because here these dimensions are very often historized. And many people in this time decided that everything needs to be historized without asking if there is any business value of it, but that's a different topic. But still you have this, you add two new columns, you need to rehistorize, you need to rewrite your fact table. At least you don't need to, the impact is only limited to the fact table and the dimension, not the other stuff, because you have a denormalized view in here. So the impact is already smaller. It was a little bit simpler to implement, and many people believe this could be a way forward. And it was in the beginning. When we had 2 or 3 source systems, this worked fine, but adding a 4th, 5th system became then exponentially more expensive. The second thing that we need to attribute to Kimball is that he made querying data very simple. Because like this, if we have a many-to-one relation from the fact table to the different dimensions, is that you can filter on any 2 dimensions or more, and you get a meaningful result. So you don't get any fanning traps, so data is not being multiplied, you can't catch like some wrong different hierarchies which are not compatible with each other. So the fact that he created a very good presentation for querying, and many reporting tools are optimized for this kind of data, it's a fact that is still true today. So yes, he didn't solve the maintainability issue, but he solved the simplicity of querying. So there is where Dan Lindstedt comes in and say, hey, we need to go back and say the normalized core wasn't too bad, but we just need to improve it. We shouldn't replace it. And the second thing is, for querying the data, a dimensional model is perfectly fine, but we should create it in a virtual way or in a rebuildable way based on a normalized core. And in fact, Dan got back just to my first slide where we say, okay, which kind of different functions data has. And one is defining stuff or identifying stuff. So we have here a single object called a hub where only the key is stored. And the key is immutable because the key is by the definition always related one-to-one to the real thing. Even we know it's not perfect, it's a model, it's simplified, it's fine, but the key is immutable. So it's one inserted, never changed. Then the attributes with the history are separated out into separate database tables. Relations are separated out in its own thing in a relation table. By this he split all the functions of the data in separate objects. And that was possible because, if I don't get it wrong, it was around the year 2000 again. Joining tables became cheaper, compute became cheaper, memory became cheaper. So it was possible to implement something that is on a physical level not that efficient as a third normal form model, but brings a lot of benefits in terms of maintainability. So still, and I need to be honest, if somebody says I need to have the most performing system, I wouldn't model this part of the data, which is usually only a very, very small part of the data, as a pure data vault, but for all the master data and everything where we usually don't have too much data, even if we have bigger companies, this is perfectly fine and it's worth it to pay a little bit more on hardware and on compute by saving a lot of efforts in implementing, changing, maintaining this system. So this is what it is about, is splitting up data into smaller bits. But again, it's nothing new. It's just a new approach just to physically store down and map the data to the different functions. So if we go further, we say we have the evolution of the third normal form here into our data vault model. Still for querying, we use the dimension model, which can be a virtual view on top of it, because this here is less normalized than this here. It's pretty straightforward and you can automate that just by definition what you want to get. Then we need a staging layer. This was unchanged since the beginning, so we need to somehow copy the data from the sources, then map it in here. This can be automated as well using the business key definition and then the denormalization as well. So what are different other approaches is that if you want to know more about anchor modeling, then read all the articles by Lars Renbeck, a very clever guy, having a lot of good ideas, solved some problems that are not that automated in the data vault modeling, but putting a lot of attributes, all the attributes in single tables, stuff like that. Have a read, it's very, very interesting. Completely different approach to data modeling took FCOIM, the fully communication-oriented information modeling, and the approach there is that business users usually are not trained in data modeling, but they can express true statements about their business, like a student lives in a city. And from this kind of sentences, you can reverse engineer and extract data models. So you can extract the things, the relations and attributes, and build a model from that. There are even tools to automating that, which is really, really cool if you want to have a read. But it's again, identifying this kind of elements. Then I have less experience with the BEAM approach, but here just for reference a book, because many colleagues of mine have mentioned this to me. And we have ensemble logical modeling, again starting with workshops in a very structured way of extracting from your business users their knowledge about their business, splitting up stuff like in events, people, places, and things, and assigning the stuff, and from there building a model. But again, it's about the conceptual model first, identifying things, later adding relations and adding attributes about it. So if you have these basic principles, you will be good in many different data modeling approaches. So let's go now to the final question. Is data modeling dead? Because I showed you history. Is this history gone? And I believe, if I'm going back to the discussion that I mentioned, is that just creating data models on paper, and if I say on paper, sure, you use software, but in fact, if you don't have any link to the real implementation in an automated way, if you don't show the value of your data models directly to your business users and they can use it and profit from it, they will not understand it. They will not participate in modeling sessions. If you don't automate the code, the developers will not understand what the data models are about. And I believe this approach for sure is dead, and for good reason. So the second problem is that back in the time when I started, we created data models like for several months before we started implementing. And again, this is not creating any value in the beginning, so this will be no way forward. So what we use is Agile data modeling. We need to link conceptual, logical, and physical implementation of these models in an automated way. And this brings benefit to the business users, this brings benefit to the developers, and this is the right way forward. So let's go in the next few minutes a little bit to the discussion. How can we link data models to real-world implementations? So before we go on, we should maybe a little bit look as well what is conceptual, what are logical, and what are physical data models. And this is not so clear. There are different definitions, different borders between different layers, but it is always about that the conceptual is about getting your concepts, your classes, your entities right, depending on what your paradigm is for modeling, but about the things, places, transactions that are happening. And the definition of it, what is a customer, what is a product, that you define that. And when we started data modeling, usually in the tools you had separations between the different kind of models. You had a conceptual model, then you exported that, you imported it into a logical model, then you exported it and imported it into a physical model. And this created problems because the models were not synchronized automatically. And this is exactly why I believe that if we want to do here something, that we need to keep all the models in place. So for me, the conceptual model is the beginning of a logical model, and then we add the relations, we add the key definitions, and by doing so, slowly conceptual model is converted into logical model. But this is for me not like two different models or in two different tools, but should be a workflow. And as we work Agile, it can be that some parts of the model are at the conceptual layer and some other parts are already at the logical layer. And for me, always important is that we have a direct relation between them, and not only from conceptual to logical, but as well to the physical implementation. This means tables created on the database, columns created, indexes created. And this should happen, in my opinion, completely automatic, because this is one of the problems in the past why we had this disconnect and why people believed data modeling is dead, because from going from conceptual to logical to physical model, it took months. And this is very difficult for a business user to understand. So the idea is here, we need to automate that. We need to make this immediately and create immediate output in the Agile paradigm. And the second problem we had with this kind of different layers is that it worked sometimes in one direction, but if people change directly stuff on the database because they had production incidents, the models were not updated. And if you have this scenario, then the models are worthless because they're not trustworthy and people have serious problems with that. So it needs to be two-way. So if we look at something and we want to make data models work, relive them, you need to go from conceptual to logical to physical in real time, in my opinion. And if you change something on the physical implementation, you should change as well your data model here. And I believe this is really the key to making data models worth to work on, because they create business value, they create value on the implementation side, and everybody is happy. And if we work with this real link between the different layers, then we need to separate our development, test, and production environment. Otherwise, if we change something to the model, we've changed our production environment, which would be terrible because we have no control, we have no versioning. And if you have just some kind of serious release management, you would be in serious trouble. So for sure, it's not ITIL compliant, and that's usually what we want to achieve. Still, we need to have the quick fix process. So if there are any troubles in production, there should be a way to fixing them, but merging back the changes into your development environment. And usually the answer to this is the ITIL process. And if we want to become really agile, then we want to work with Git and Git flow. And we want to do something that's called distributed development. It means that we want to develop different features or different stories completely isolated, have them on different branches in Git, and like this we can decide on which of the features will be deployed, in which order, and we have complete freedom, we have full control, we have full versioning, and this was invented before. So the Java people defined for that they have a working folder on their local machine, so you have a central Git repository, you create a branch, you check it out into your local Git repository, and one of the branches is then in your working folder, and you're working on this one feature. And the problem is that we don't have this equivalent directly in the data warehousing world. We're working with databases, with data, and somehow we need to make this work. And for me, the equivalent of a working folder in the Java world is a sandbox. And so we need to see how we work with sandboxes, how we synchronize between sandboxes and the development environment, how we bring this into the Git flow-based process. And some other people were at the same point, and they had a different answer to this. And their answer was use or define pipelines as code. Because if we have code, we can use this working folder approach. We're working with files. We can use the fully Git flow-based process. And they're right about it. It works. You can branch your stuff if you have it as code. You can merge your stuff so that the basic tests are there. You can do automated testing. You can do pull requests. You can then work on different branches and define your deployment orders. So this is very cool for achieving CI/CD. There's one major drawback, and this is really the approach that probably if you heard about DBT or DBT Vault that we have, is the modeling part is missing. So giving meaning to this. So this is all this history that we have, that we created for a reason, for communication, is gone. It becomes business driven instead of everything that we did in the past to make this process business driven. So technology instead of business driven. And the whole meaning is lost, and it's only in the code, and so you need to reverse engineer the code. And yes, the developers can do that, but the business people can't. So the question is, can we achieve the same and not lose the modeling aspect? So how can we make data models ready for continuous integration, continuous deployment? And the first thing is that we need here is to have an agile data model. And here Data Vault helps us, and this was one of the basic ideas. We are adding all the new elements, and by adding always new elements makes it much simpler by not getting into conflict if we try to merge different data models. And the basic idea is that we can start small, changes are cheap, and changes don't become more expensive the longer we build. And by this loose coupling, this is guaranteed. So we have add only, we have no dependencies between the objects, so we can deploy them as well in different orders. We could start the data model creating at 2 different places, and we know it grows together later. So from a modeling perspective, that's already very good. The second thing is we need to have a completely automated way to transform a modeling artifact into a physical artifact. And here, this is perfectly fine because we separated already the functions of data into different modeled elements, and now we can, in a deterministic order, transform a hub into its physical representation as database table or whatever it is in the physical world, and we can take the physical table and transform it as well into the logical object. And now we need to take this kind of objects and describe them. Yes, we could take the database table and check it into Git. It would work, but still we would lose the metadata and everything. So what we decided is to represent the data model in the way that Git needs it, as files. And this is pretty simple because we can take every hub, every link, every satellite, and for every object we create one single file. We make these files human readable. So if I need to have some conflict resolution at some point because my colleague maybe did put a different comment for my hub than I did, we will see that, we will understand it, and we need to sort these files, we need to prettify these files, and then it will work that we can use branching and merging at the logical model level. And now we have the same as the data pipeline as code people, but with additional meaning. We have a means of communication, we have documentation created, we can really explain to new colleagues how stuff is related, we can talk to the business people, we can export our metadata automatically into their reports, and they will benefit now from what work they did put into the data modeling efforts. And this is closing the gap, giving benefits to developers, giving benefits to the business people, and now we have our data models alive, and this is the way as we see it. And this is what the data vault builder is about, and what I can show you in a few minutes, how we use the data vault builder to make this modeling to code process completely automatic, how we can make deployment automatic, how we can automate operations and everything around it. As I mentioned in my slides, we believe the data model should be the starting point. And here we look now at the data vault builder. And in the data vault builder, we have here different layers. We have the staging option, we have a data viewer as data profiling tool, we have the data vault part where we have the data model of the core. We have then the dimensional model to create our output interfaces. They can be dimensional, but they can be flat tables, they can be data products, they can be third normal form views, because everything is less normalized than the data vault. So it's pretty simple to denormalize everything down to that level and automatically create that by generation. We have then a section for business rules where we can put in whatever your business needs, aggregation rules, concatenating fields, creating new values, deriving values, whatever is necessary. Then we have a section for the data lineage, which shows us how the data flows from the source to the target. We have operations section where we have jobs automatically created for data loads and a scheduler to run the jobs. We have a documentation section and we have a deployment module. And in fact, here I started already with the deployment module, loaded a data model that we created in a workshop with some business users into my local instance. I loaded this from our Git repository, and this data model was created in a 2.5-hour workshop with a business user that is a ground handler at the airport. And we talked to them, what is their starting point for reporting? What do they need to know to improve their business processes? And they explained us that everything starts with the flight. They are servicing flights, so that's their main business process to earn money. So we added here this blue box. This blue box represents a core business concept. If you come from ER modeling, it would be like an entity. If you're coming from more like object-oriented world, it would be a class of objects. It's representing the thing itself. In the data vault modeling, this will be the place where we store all the business key identifying this thing, in this case the flight. The next thing that we have here on the diagram are these big colorful bubbles. They are just grouping stuff together. They're so-called subject areas, not really necessary to express the model, but it makes the model much more clearer. And you can use this as data domain boundaries if you are doing something like a data mesh to differentiate which team is responsible for which part of the data. What we see here as well are relations, and these relations can be many-to-many or they can be directed, so they contain as well the information about cardinality. For data vault modeling itself, we would need that information, but it's important as we want to denormalize the data model later on, so we need to have as well information about the cardinality. And we have these small dots, they are satellites. They will have the context attributes or description about the concepts And here the historization will happen. Here as a next element, we have a relation which is linking together more than two elements. So it's not a binary link, but it's a unit of work link. We can do that for several reasons. One is performance, to group relations together into one element. And the second thing is about the logical thing, a so-called unit of work link. So if we know that a flight usually has an origin and destination airport, otherwise it had a problem, obviously, then we can group this stuff together and express it as one relation from the flight and saying it's going from the origin to a destination. And here we have something more. We have here role playing, and we can use this role playing to make the model more clear. And we can use that later on as well to create role playing in our reports. So we can filter for the destination report and we can filter for origin airport, and we don't need to write any code to do this kind of role playing. This model is in fact bigger. We can browse through the model. I'm just showing a part of it because usually if I'm working at a specific point or at a specific story, I don't need to see the full model because the full model can have several hundred objects. And here I can concentrate on the parts I need to see. I can bookmark and recall this bookmark later. I can share this kind of bookmarks. And the cool thing is we differentiate here between developers that change the data model, that need to have a license for the tool, and the read-only access is completely free. So all the business users can access this kind of information at any point in time. But as well, we make this metadata in a very simple way exportable, so they can include this, you can include this metadata into your reports and deliver the business value where your business users are in your Power BI, Click, Tableau, whatever report, so they don't need to switch between tools and they will see what the definition of a flight is. And now, if we deliver this kind of information back, it makes sense that they start to work with you. And you can add the definitions here. You can push definitions from a data dictionary in here, and we can export it towards the report. And now this gives the value for the business user. So he can see the model, he understands the relation, he can later on automatically select from this data model, and it will create the interface. It's completely automatic for him, and he gets access to this metadata in the tools he's already using. For the developers, the big benefit is that if I'm adding here an element, so let's add here something like a car, and let's group this into vehicles because maybe our flights are serviced by some cars at the airport. In the same second, I'm adding here something as a concept to my data model. It is as well implemented physically on the database. So there's a database table existing already. It has the 4 columns given by the data vault standard. It has some technical namings for the different columns like the hash key, the business key, the load time, and the source, which are used for debugging information. So it's already production ready implemented table at the physical model, and it's added here as a concept, and we can link it and go slowly to the logical model by adding here relations. So I can add here a relation from a car that is servicing a flight, and many cars may service many flights, and many flights are serviced by many cars, so it will be many-to-many relation. And as well here, slowly getting to a logical model doesn't mean that we swap between different models, but slowly we are evolving the conceptual into the logical model, and at the same time as well for the relation, the physical implementation is happening instantly. So this is cool for creating models, creating structures, but now we need to bring in the data. So we're switching now in a data-driven perspective. This here was the model-driven perspective where we have the business view. So let's go back to our staging area. Here we have built-in ETL connectors, but as well ELT connectors. So we can say, okay, we want to here having a new flights Europe system. We could go into the connections. We have a lot of built-in connectors where we can pull the data from. I have already prepared one of these systems here as a CSV file source. I can now select from the data that I have there. So the different CSV files are recognized as automatically as tables. I can select the columns. I could rename the columns. I can put on comments. If there are already metadata present in the source system, we can read that and import it But here, as it's a CSV file, we are not doing that. As well, I'm skipping now a lot of steps, like we can define here CDC loading, we can define here delta loading, we can filter data, and we can write custom queries if the source data doesn't have a proper data model. And here we see again the direct implementation in the target. So it will create a target table, it will create a ETL flow, it will add it to documentation, it will add it to data lineage, and immediately load the data. And this now gives the benefit that by adding stuff to our modeling solution, it is implemented at a physical level in real time. So this data is already loaded, we can have a short look. And because there are a lot of columns, let's have a look on the data in the database in our data viewer. So we can group here data, we can have a look on the value distribution, and we see here already what the values are. And this can give us a very early insight and communicate back with the business user about which kind of data is there, if there are any data problems that we already see with business rules that are formulated or business keys are not filled for many records, stuff like that. Now the next step is, after first step we created a model, second step we staged the data, we now need to bring these two perspectives together. And this is done by defining the key. So we are now going slowly from the conceptual level, creating the concept, adding relations, and now adding the keys. So it's a continuous flow from conceptual to the logical data model. And here now we can look for the business key. So it could be something like the flight number, and it could be like the date of the flight. And again, we can test our assumptions, and this is about agile working. And if people say fail early, it doesn't mean you should fail, but that in case your assumption is wrong, that you detect it very early. And this is what we do here. So the tool gives you automatically if there are any duplicates, it shows you sample data sets, and it points you maybe here visually to the column that is the problem. So we have different unique carrier codes for the same flight number. So we went back to the business user and he explained us, yeah, that makes sense, that's code sharing. But the main advantage is this business user doesn't need to give us feedback in the dark. We just don't go back and say, hey, it's wrong what you told us. But here, there are some samples. Can you, by looking at the samples, identify what the problem is? In this case, it's the origin. So let's add this as well. And like this, we can progress much faster. So now we did already 2 or 3 iterations on our model, on the key definition, without losing any time, without waiting for generation, without waiting for data loading. It's happening instantly in the process that we define this stuff. And now the tool has enough information. It knows the concept, it knows the key, it can now create all the loads, it can create all the historization, and we have already production ready load into our data model. So we can go in here and start this load. And now the beauty of standardization kicks in. Because we're having here already some naming standards, we have already some load pattern standards that are coming with the tool. I don't need to define anything. It goes back, it updates the staging table to add business key and hash key definition, and it loads the data after doing that. So the data is here, already loaded, production ready load. It was added to operations, it was added to documentation, and the same for the satellite, including STD type 2 historization. We have solved a lot of problems that you maybe didn't thought of yet, like implicit deletes in your source systems, and we have tracking satellites. If something was removed from the source, you don't get any information about it. This is tracked automatically. We can start the load directly here, but as in the background a job was created automatically for the source system, we can just go here to our operations module, start the job directly. We can schedule it here automatically and we'll start collecting history, or there are REST APIs for everything, so everything could be triggered externally as well. So we are happy, we loaded the data into the core, but something is missing. And what is missing, we need to create the interface. This is like this dimensional view that I explained in my slides, but it could be as well flat tables, it could be third normal form if you're going in directions of sub-business objects or cognos. So we define here what is the grain, if you're following Kimball's question, and we define now what is our initial data set. We can define what is the temporal view as we already created history in the data vault, we can select if we want to just get an as of now perspective. If we want to get an as of then perspective, then it will create a so-called pit tables at the physical level, but we don't need to care about it. This is the physical implementation. It's driving automatically. Here we're caring about the business requirements. Do we need as of now view, or do we need the full history in the report? We just define that everything is happening automatically in the background. We can create more than one interface per object, because maybe we have dashboarding, we have legal reporting, we have data scientists, and they need different levels of denormalization. That's perfectly fine. Or you want to create maybe data products for other applications. So we can now visually select from our data model, select some random columns. And this view is in the first version always virtual, so we can directly look at the results. We don't need to reload anything. And this is what now the business user can access directly. And now you see that working with the model is creating immediate value for the business user. We can go and just publish this information as it is. Even if it's not perfect, we're working agile, so we can add some modifications and harmonizations and stuff like that later. But now this is the minimal implementation to load data from a source system into the core and create an interface to output it. So now we can call our business user and tell him, hey, that's fine, you can check your report the first time. So we can maybe take here the flight date. We can do here like a small representation as bar chart, and check if our data makes any sense. And this is what the data vault builder is about. Taking data modeling, exposing the metadata to business users that they profit from it, and as it gives them value, to include them in data modeling, and to help the developers to implement stuff faster in an automated way, so they start using data modeling as well, bringing everything together, making it agile, and bringing value to everybody. And in the background, automatically data lineage was documented. So if you need something for like your GDPR reporting, you know exactly how the data flows are. You have a completely automatic documentation that can be generated. And this is not hypothetical documentation. It's not based on the model that we created, but it's now reading the implementation. And based on the implementation, it's creating documentation and as well the data model that we have here. If I would go and change something physically at the database level, it would update as well the data model. So we don't have the problem anymore that the data model and the implementation could get disconnected. So this one instance of a database and the data vault builder is my sandbox. And now some people get afraid and say, yeah, but if I'm changing something and the implementation changes right away, how it will affect my operational production system? And it will not, because we are doing these changes either on an integrated development platform, if you have like 2 or 3 developers, or in your own sandbox, if you have clients with up to 40 developers. So everybody has its own sandbox, they're working with it. And then there is a deployment module where we can now do calculate differences between our local instance and our target instance, and it gives us exactly what the differences are. And there is as well the support for a Git flow-based process. This is too much for a first introduction, but everything is covered in the tool. It's calculating dependencies, it's creating deployment files automatically, and as well it allows you to check in your data models in Git with branching and merging, so you can achieve the full CI/CD workflow as you would if you would have your pipeline as code. But additionally now you have this visual representation, you have the metadata, you have meaning in your data.